Today we are going to be solving equations based on angle relationships. We're going to be looking at pictures and trying to pick out what angle relationships do we see that can help us solve for variables. So in this problem here, we actually see 3x, and our goal is going to be to find out what value of x makes this picture accurate. Now, we don't want to use protractors when we are trying to solve for a variable in this situation, because it can be very difficult on how accurate we are and how oftentimes people make mistakes, and if we're off by 1 degree, it could throw off the entire problem. So our focus here is going to be to create an equation from this, turn it into something that we can solve, and get our answer that way. And we'll even go over how to check as well, so you can see that it actually makes this true. So in this problem right here, we have many different things to look for, and I actually have multiple slides here that I'm actually going to try to show you different ways of solving this. Now, in this problem here, the first thing that I would do, the quickest way to solve this problem, is to look at what we see here and what do we know. Now, in this problem, we do have two adjacent angles. These are two angles that are next to one another, and we know they're adjacent because they share this common side right here. That common side is shared between them, meaning that only these two would I be able to add together to see what they're equal to. Now, I also could add some angles that I don't know at this time, but I wouldn't really want to add my 3x to this mystery angle, because that would add in another unknown into this problem, which means there's an infinite number of solutions. So instead, I'm going to solve this the quickest way I can, and I'm going to focus on this 3x and this 16 here, because those are two adjacent angles that I can add together. And I'm going to overemphasize that during this video and say that these are adjacent angles, because I can add them to each other. Now, as you notice, we also have an 85 over here, and this 85 is not something that we can just ignore. It doesn't just disappear. It's also important in this problem. Now, I can't add the 85 with the 3x and the 16. It's not adjacent. There's this mystery angle that we do not know over here. Now, I don't need to solve that angle. We can actually solve this without here, but we need to know some of our math terms. What we have here are two straight lines being formed, two intersecting lines. And whenever we have two intersecting lines, we have what we call vertical angles. Vertical angles, I like to call them vertical angles because this almost looks like we are forming a V and an A. Vertical angles, that's how I remember this. But what it tells us is that opposite angles are equal to one another. So if I were to label this angle right here, this angle right here is the exact same measurement. But what we are going to use right here is, with these vertical angles, it tells us that this angle KEL is equal to the sum of those two adjacent angles that we just talked about, JEM. So I'm going to actually create an equation here, and we're going to actually show that these are equal to one another. Now, since these are equal to one another, I can say that these two adjacent angles can be added to one another. 3x plus 16. And this is going to be equal to, of course, the other vertical angle, which is 85 degrees. And once I have these here, I can actually solve this equation, subtracting 16 from both sides. 3x is equal to 69 degrees, and then divide by 3 to get my value of x. And I can always check this how I want to. We know 3x is 69 degrees. 69 plus 16 does equal 85. We know for a fact this has to be the correct answer. Now, instead of checking this like we normally would, I'm actually going to check this by trying a different way. using a different angle relationship to solve this problem. Now, we've already discussed that I cannot take this 3x and really talk about any other angle other than the 16 at this point, because this is the only one that is adjacent to it that I actually know a measurement of. So instead of dealing with the 3x first, I'm going to actually start with the 85. Because even though we don't know the angles that are next to 85, we do have an angle relationship here. If we take a quick look at this, we have a line here with JEL. Or if you didn't want to use that line, of course, we could always use this one of KEM, which is also a straight line. Now, every single straight line adds up to a total of 180 degrees, which means this angle KEL added to this angle LEM is a total of 180 degrees, and I know one of them. So some number plus 85 has to be 180 degrees. Very quick way to solve this here. X is 95 degrees. I probably shouldn't have used X there because I already have a different X here. That would be any unknown. Maybe we should have used N here. Some sort of different variable here. But we know this angle measurement is 95 degrees. And I would also write down this one also is actually another 95 degrees. We know this because they both form a line with this 85 degrees. So I could have used either one of them. They're vertical angles as well. We already talked about that earlier, how they're on opposites of those two intersecting lines. And now I have other options to solve this. Because I'm dealing with this straight line and we're talking about this, I'm going to use angles on a line here. Angles on a line means that any line forms 180 degrees, just like we used to find this 95. I'm going to do the same thing once again. For emphasis here, I'll draw another line, the one that we just found. And this line here, once again, to overemphasize this, is made up of those three angles. Which means if I take my first angle of 3x, add it to my angle that is 16 degrees, I know that, and now I can also add it to this 95 here. This is going to be equal to 180 degrees. Solve this equation, combine my like terms, 111, 3x plus 111 equals 180. Subtract 111. 3x equals, once again, you see this happen again, 69 degrees. Divide by 3. Once again, x equals 23. I'm not going to label that with a degree symbol there because x is a variable as part of the entire angle. But once again, we got another answer of 23 as our value of x. Now, if you were looking at this saying there's two ways to solve this, that's awesome. There's actually a third way, and this has to do with what we just did here. If we found out this was 95 degrees and this was 95 degrees, we do not need to use angles on a line. We can use our last angle relationship that would be relevant in this problem, which would be dealing with the entire image that we have here. All of these angles combined, we add them all together, they form a circle. We cannot use angles on a point, which this is called, if we don't know all the angle measurements or have a variable for them. In this case, we now have enough information that at this point, I can create a giant equation to solve this right here. This giant equation would look like 3x plus 16 plus 95 plus 85 and then plus my other 95 equals a circle, which is 360 degrees. Now, just like we had before, make sure to include all 1, 2, 3, 4, 5 angles right there, and then we solve this. Combine all these terms here, all these like terms, 291, still plus my 3x, minus 291. If you have not seen the pattern yet, you will see it in just a moment. 3x equals 69 degrees. Once again, that entire angle divided by 3. X is once again 23. 3 different ways to solve this problem. You must look at what angle relationships you have, and whatever you notice, there is a way of figuring out this problem.